So here is another question on projectile motion with angular projection. So here it is given that two projectiles are thrown with different projection velocities, that is initial velocity, and at different projection angles, but they cover the same maximum height. Okay, so as to cover the same maximum height, we have to show that the sum of the time of maximum height of the two projectiles, okay, it is equal to their individual time of flight. Okay, so let us try to first understand the question. Okay, so let's say this is the first case, the first projectile. Let's say it was launched with initial velocity u1, projection angle theta 1, and it went to a height this much. Okay, h max 1. Then we have another projectile, the second projectile. Let's say it is launched at the initial projection velocity u2, and let's say the angle is theta 2, and this also reached the same height as the first projectile. Okay, h max 1. So here it is slightly, this is pointed. Okay, so this is like this. Okay, so they have the same height. Okay, h max 1 and h max 2, they are the same according to the question. So here the formula of maximum height becomes very crucial to solve this whole thing. Maximum height is equal to u square sine square theta by 2g. This is the formula. So for the first projectile, the maximum height is equal to h max 1 is equal to u1 square sine square theta 1 by 2g, and for the second projectile, the maximum height h max 2 is equal to u2 square sine square theta 2 by 2g. According to the question, h max 1 is equal to h max 2. Maximum height for both of them, they are the same. That implies, let me use a different ink. Okay, u1 square sine square theta 1 by 2g is equal to u2 square sine square theta 2 by 2g. So both sides 2g, it will get cancelled. Then taking root over on both sides, we have u1 sine theta 1 is equal to u2 sine theta 2. This is the important point. Okay, this is the first point. This is very important. Now, if you remember, we have not solved any question related to this important parameter, which is the time of maximum height. It means for angular projection, how much time the projectile took to reach the highest point, the peak point. This is called as time of maximum height. We have solved it in the derivation part. So time of maximum height, if you remember, we derived it in the derivation part of angular projection. It is equal to u sine theta by g. Okay, u sine theta by g. This is the formula of time of maximum height. Now the time of flight formula, what is that? Time of flight formula of an individual projectile, that is equal to 2u. So the time of flight, that is equal to how much? 2u sine theta by g. Okay, so the time of maximum height for this first projectile, that will be equal to u1 sine theta 1 by g, and the time of height for this second projectile, it will be equal, maximum height for the second projectile, it will be equal to u2 sine theta 2 by g. Then time of flight for the first project, know the difference. Time of maximum height is the time taken by the projectile to reach the maximum height. Time of flight is the total time taken by the projectile starting from ground level to again reach the ground level, from here to here. Okay, from ground level to ground level. Maximum height is from ground level to the maximum height. So TH is the time of maximum height and TF is the total time of flight, the total journey, time taken by the projectile to complete the journey from ground level to ground level. So time of flight for the first projectile TF1 is equal to 2u1 sine theta 1 by g, and the time of flight for the second projectile is equal to 2u2 sine theta 2 by g. Now here is the important thing. Here we have proved that u1 sine theta 1 and u2 sine theta 2, that is the vertical components of the initial projection velocity for both the projectiles, they are the same. Okay, they are the same. So it means the time of maximum heights for both the projectiles, it will also be the same, because g is constant in the denominator. Here th1 is u1 sine theta 1 by g and th2 is u2 sine theta 2 by g. Here these two are constant, these two are equal, we have proved here according to this, and g, acceleration due to gravity, it is constant. So automatically time of maximum height for both the projectiles, they are equal. Also the time of flight 2u sine theta 1, 2u1 sine theta 1 by g and 2u2 sine theta 2 by g, that will be also equal by the same thing. You know, time of flight of the first one is equal to 2u1 sine theta 1 by g, and time of flight for the second projectile is 2u2 sine theta 2 by g. 2 it is the same, and g, that is also constant. Okay, they are constants in both the thing, and u2 sine theta, u1 sine theta 1 and u2 sine theta 2, they are the same according to this. So time of flight of both the projectiles, that is also equal. So these are two important conclusions. Then for the proof that the sum of the two maximum heights is equal to the individual time of flight. So now we will add th1 plus th2. So it is equal to u1 sine theta 1 plus u2 sine theta 2. Now as we have proved that u1 sine theta 1 is equal to u2 sine theta 2, we can write it as in two ways. Okay, as they are both equal, we can write it as u1 sine theta 1 plus u1 sine theta 1, or we can write it as u2 sine theta 2 plus u2 sine theta 2. So in this case it will be equal to 2 u1 sine theta 1. In this case it will be equal to 2 u2 sine theta 2. And in both the cases it does not make any difference because they both are same, which we have proved here. Time of flight or of both the projectiles, it is the same. So it is equal to their individual time of flight. Okay, so here we have proved that the two projectiles which were thrown with different projection velocities and at different angles with the same maximum height, the sum of the maximum, the time of maximum height of the both projectiles is equal to their individual time of flight. Okay, so this we have proved. And along with that we have proved many other things in the way such that the time of maximum height for both of them will be equal, the total time of flight of both of them, it will be equal, the vertical components of the projection velocities of both the projectiles, it will be equal. So a lot of things we also covered in the way. Okay, so this is the thing.